Four robotaxis rolled into a San Francisco intersection and did something remarkable. They all followed the rules perfectly and ground to a complete halt. No crashes, no malfunctions, no edge case sensor glitch. Just four machines being so polite, so cautious, so technically correct that they paralyzed each other. This one quiet incident exposes a fault line running through the entire autonomous vehicle industry. The autonomous vehicle industry has poured billions into benchmarks: object detection accuracy, lane keeping precision, obstacle reaction times. These numbers have improved dramatically year over year, and that progress is real and meaningful. But here is the uncomfortable truth. A city intersection is not a perception problem. It never was. It is a social coordination problem, dressed up as a traffic engineering problem, and our benchmarks were never designed to capture that distinction. Think about the last time you navigated a busy four-way stop. You did not wait for a mathematically perfect green light. You watched someone's steering wheel twitch 2 degrees left. You caught a driver glancing at their phone. You noticed a car that crept forward half an inch, an unmistakable social signal meaning, I am going next. You processed all of that in under 300 milliseconds and made a confident commitment. That is not sloppy human behavior. That is an extraordinarily sophisticated social computation that took decades of evolution and years of practice to build. Every urban traffic system is built on a hidden social layer that sits beneath the written rules. The unspoken you go, I'll yield handshake. The eye contact that settles a dispute between two pedestrians and a turning car. The assertive 2-second pause that signals intention without aggression. Autonomous systems optimized purely for rule compliance are essentially fluent in the written language of traffic, but completely illiterate in the dialect that actually keeps intersections moving. Deploying rule-perfect systems into socially negotiated environments is the core mismatch the industry has not yet solved. The Robotaxi deadlock has a striking parallel in large language model behavior. Models trained to maximize caution and minimize incorrect outputs often produce responses so hedged, so probability-laden, so non-committal that they become practically useless to real users. A person asking for a recommendation does not want a distribution of possibilities. They want a decision they can act on. Excessive caution is not neutral behavior. In both autonomous vehicles and AI assistants, refusing to commit in ambiguous situations is itself a failure mode, just one that does not show up cleanly on standard benchmarks. The technical path forward is clear in concept and brutal in execution. You have to train on the messy, negotiated, socially loaded layer of human behavior, not just the clean rule-based layer that is easy to label and easy to measure. But there is no neat mathematical loss function for assertive enough without being aggressive. There is no benchmark dataset for confident commitment under social ambiguity. Building these training signals requires rethinking how we collect data, what we label, and what we define as success. It is some of the most genuinely difficult open research in the field right now. It would be comforting to dismiss the San Francisco intersection incident as a quirky edge case that engineers will patch and move on from. But edge cases at small deployment scales become systemic failures at large ones. When autonomous vehicles are a minority of traffic, human drivers fill in the social negotiation gaps intuitively. As autonomous vehicle density increases, there are fewer humans performing that social lubricant function, and the brittleness of purely rule-based coordination becomes increasingly visible. The deadlock was not a warning about one intersection. It was a warning about the architecture. The most important sentence in this entire story is the one that should be hardest to sit with. Nothing broke. Every system performed exactly as designed. The lesson is not that autonomous vehicles are dangerous. It is that correctness and sufficiency are not the same thing. The next frontier of AI development, whether in robotics, language models, or any system deployed into human environments, is not about achieving higher accuracy scores. It is about developing the kind of contextual social intelligence that lets machines participate in the collaborative, ambiguous, deeply human process of getting things done together.